Good morning, everyone. Thank you for joining and attending this WebEx related to identity access proxy for F5 or the zero trust model and how F5 is reaching out for this zero trust model. Today, I'm Thierry van Stertigem, who's hosting this from Exclusive Networks, who is hosting this WebEx, together with Koen van der Poorter from F5 and Stefan Leroux, also from Exclusive Networks.
Good morning.
This webinar will be recorded. During the webinar itself, we are kindly asking you to create a question via chat. And at the end, since we are with a small group of attendees, I will unmute the microphone so that you can get your question when related. We are recording this session also. So after the presentation, a mail with a record of this session can be sent out, and also parts of the presentation will be sent out also. Regarding the session itself, first we are going to start with a small introduction on Shape Security, a company which is acquired by F5 in the beginning of this year or last year. Then we are going to focus ourselves on what is zero trust, how F5 is achieving the zero trust, and then afterwards we will do a demo on the implementation of zero trust itself. At the end, do not go away, because we have a small Q&A session, and we have also a small review of the session together with Kahoot, so that we can poll on your interest and what you find of this system. Before we start, before I will continue, I'm going to give over my screen to Koen, that he can present you some parts on Shape Security. So Koen, screen floor is yours.
Okay, 1 second. Let me pull this up. Up. Okay, can you see my screen, Thierry?
I can see it.
1 second, I have to put this in presentation mode, I believe. Okay, so thank you very much. My name is Koen van der Poorten. I'm a system engineer at F5. Today we will mainly be talking about zero trust and how it can be accomplished with F5. But before we dive into that, I would like to take a couple of minutes, just 2 or 3 minutes, to talk about our latest acquisition. It's a company named Shape. To be honest, for me as well, it was unknown. It's mainly, it has a footprint in America right now. So it's quite recent, since 2011 that it exists. We acquired it end of last year, I believe. But make no mistake, if you look at the customers they have right now, you can see 3 of the 4 top US banks, 6 of the top 10 airlines. The biggest coffee retailer in the world is another customer. I guess I don't have to tell you who that is. That was, by the way, their first customer. And you may ask yourself, of course, why did F5 acquire them? Well, the way we see it, it is an addition to our capabilities to detect fraud, okay? I believe everybody in the session is more or less familiar with AWAF, our advanced WAF, who has anti-bot detection and mitigation capabilities. But I have to say, Shape goes way further than that. What they do in a nutshell is fraud detection and mitigation. The thing is, if you are a retailer, or if you have a web shop of some kind, or an online portal, you never know who is connecting. And it's often a mix of good users and bad users, okay? Can be bots, can be real life hackers, can be hacking farms like companies that can be hired to manually try to hack into your company, etc. Okay, so for a system like ours, for advanced WAF, we can do a lot, but it's quite hard for F5 advanced WAF, for example, to distinguish manual abuse of functionality. And what do I mean with that? Well, a very good example is a British customer of Shape. It's some kind of a sandwich shop. They gave out on, if you registered yourself as a new customer on their website, you get a voucher that allows you to go and get a sandwich for free in one of their shops. So what happened was that malicious people, or people with malicious intent, mass registered through bots, but also through click farms, let's call it like that, as new customers. They then got the vouchers who got exhausted in the web shop self. And then they started to sell those vouchers online. Okay, let's say that a voucher is worth, I'm just saying something, £10. They sold them for £5. So essentially what they did was abuse a promotion to make monetary gains out of it. Okay, and you can easily understand that for a system like a web application firewall, it's near impossible to detect that. Okay, so that is the sweet spot for Shape. Okay, so the thing is, of course, a lot, and even in these days of Corona, for a lot of retailers or shops, the online presence is the only presence that they have right now. So it is of vital importance that they protect it as good as possible. Now, the thing is, these kinds of attacks are getting cheaper by the day. Stolen credentials, credentials that have been leaked at some time can be found for $0 anywhere, or maybe bought for $5 for 1 million username password pairs, for example. Then you can engage a botnet, for example, at $2 per 1,000 IP addresses or hosts or source IP addresses. And once you have that, you can then start to attack or use these stolen credentials to try to get into a web portal, okay, by simulating login behavior. And even if you try to protect yourself as a web shop owner with a CAPTCHA, there's two problems there. First of all, it can also be solved. You have CAPTCHA solving tools, which are essentially rooms full of people solving CAPTCHAs for you, somewhere in the East or wherever, in Africa maybe. And second of all, it deteriorates the user experience. People don't like clicking on buses or traffic lights or stuff like that. If I have to do that, I feel like turning away from that website, okay? So the thing Shape is doing, and it's doing it by, they have, I'm not going into the details about the technical part, just looking at it from a high level. There's machine learning involved, there is artificial intelligence involved, there is also no, I'm not calling it crowdsourcing, but the thing is, the fact that Shape is deployed at all those very large customers also means that Shape has a lot of intelligence which it shares across other customers. So even if you have a tiny web shop, you can profit from the intelligence that is brought to you by a customer like a big coffee vendor or stuff like that, okay? And there you can immediately see the value, of course. So they work in different layers. The first layer is filtering out, let's say, the automated or the high level bad traffic, all the bots or the simpler things. That way we can stop credential stuffing, CAPTCHA bypass, spam bots, etc. You can see for retail, for example, it already filters out up to 90% of all visitors coming into a web shop. Second part is then the smarter guys, the people themselves, the hackers themselves. And there we have loads of very smart algorithms to detect them, okay? What's also important is it evolves constantly. If one of those hackers would detect that a solution like Shape is blocking them, what they would do is retool or try to find another way to hack into it. And a lot of existing let's say, solutions or anti-bot solutions will keep on doing the same kind of protection so they can be evaded. What Shape does is continually rewrite the protection engine in order to adapt to the attackers. So we will constantly be on top of them, and they will constantly have to recreate their attack tools. And the goal, of course, in the end is to wear them out, to make them stop, okay? So it's really a very smart thing. And the ultimate goal, of course, is only to let the good guys in. Even better, the fact that we are sure that they are only good guys will allow us to get rid of that stupid bus or traffic light captcha, or maybe that online two-factor authentication, okay? And that's in a nutshell what they will do. So the sweet spot for customers is, of course, retailers, etc., large online presences like banks, etc. Okay. So to close this off, here's a real-life example of what happens when you deploy it. The red thing is in the graph you can see the green traffic, that's regular users. The red traffic are the bad guys, and you see that they can be filtered out up to almost 99.5%. Okay. And that makes that it's not only a technological solution, but also a business solution, because it allows customers to gain money or to save money. Okay. That's it in a nutshell. We'll come back to that, of course, later on. But for today, let's now focus on zero trust. Okay, over to you, Thierry.
Okay, thank you, Koen. I'm going to share my PowerPoint again. Okay, regarding zero trust. Now, a lot of vendors nowadays, they have the same principles. Then they are explaining you what zero trust is. And in fact, zero trust at a certain moment in time, what you do with zero trust is you will not allow anyone not by his username, not by his device, not by his application, to access your environment. Why? As you can see already, a lot of web applications are breached. When you combine it with a lot of bad identities, they are breached also. And when you see it with the identities itself, then you see during time, over time, that the way how people have to log in, the way how people are trusted over time, it's also different. So more and more, we do not trust anymore people, applications, and so on. So therefore, a system is built like zero trust to allow people on adaptive basis to allow people to log in into our environment. So there are different security designs to get access to our applications. In the beginning, when we had only the F5 system with LTM, the authentication layer was built on the application itself. So the only thing that we did on the F5 system is just doing some parts of load balancing. Authentication was built in the application, and we couldn't tell the bad guys, okay, you cannot log into our application at a certain moment in time. They knew what type of application it was. They knew the weak points, so they were getting access into our application. At a certain moment in time, okay, our attack surface was too big, so we had to change some parts of it. And then suddenly we added some remote access onto our system, But at that moment, we only take control over the people logging in from the external or from the internet. So attackers at that moment were not allowed to log in anymore. But what were we planning to do with internal systems? But it was only remote access. We didn't control any internal authentication mechanism. So when our user was logged on onto our external proxy, he had to re-log on the application again. Same thing for the internal users, they have to log on the application. But the bad guys or the attackers in our environment, not from the external, not from the internet, but from our LAN, they had still the same opportunities to log in onto our applications. So we have to shift it again. And then you see, therefore we have to shift it again so that we have to adopt also mobile and cloud technologies. At a certain moment in time, we have to adopt multi-factor authentication and other requirements so that we can move people from internal and from external, that we move them to the same system so that we do not allow any access anymore, not from our internal clients, not from our external clients, to our internal applications. So everyone has to log in from the same point of access, and then this access can then be reused into our application. So the control point itself is becoming our F5 APM system. So zero trust at that moment is that we're not only allowing a control of our user, but we are also going to control the device itself of the user. The next step, of course, is something that we see more and more, is the integration of IDaaS. IDaaS is a new Gartner quadrant, and the new Gartner quadrant contains some vendors like Okta, like Microsoft Azure, where they have an identity as a service. So these vendors are they are creating their systems in a way that they are gathering all the identities, they are controlling all the identities, and different systems can reuse these identities which are controlled in the cloud. So why it is attractive? It's federated, a single point of control, and you as an administrator at that moment can start to define what the user can do and how he has to log in. So therefore he can use it federation, and we can ask the user to do some multi-factor authentication. But there are a lot of problems nowadays. It's less and less, but the first line is the most important one. When an application is not integrated by default in the IDaaS environments, what we are going to do at that moment? When our multi-factor options, we do not want that we are going to use a multi-factor system from the IDaaS provider. Do we want some other vendors? So therefore, we have some other problems. What type of multi-factor options do we allow? Another thing is everything related to identities itself. An IDaaS provider, the only thing that he does is storing the identities and controlling the identities. But everything related to security, that's not, most of the time, not a part of the job that they are doing. So therefore, we are going to integrate it with F5. So therefore, F5 APM can solve the security problem, and it's going to use the IDaaS provider as an identity provider in combination with federation like SAML or OpenID. So therefore, we are going to integrate the identity control, and F5 at that moment can help you to organize zero trust. So at that moment, F5 APM is able to control the user, to control the device, and to control access to a specific application. It doesn't bother what type of cloud we are logging in. It doesn't bother where we are logging in. Our user is always contacting our device, our F5 system. It's the F5 system at that moment that's going to request to our IDaaS environment, I have here a user, please control the username and the password and maybe the multi-factor requirements. So when the IDaaS system tells us, okay, he is allowed to log on, that authentication mechanism or that authentication credential is then forwarded to the application itself. So the bad guy, at that moment, it's already blocked at the F5 and is not allowed, he will not be allowed to log in into our application itself. So we have one single point of contact where we will control the logins from our attacker or from the normal user. So this is not new for F5, and that was always the case, what we did in the past also with F5. But therefore, we have replaced also many TMGs. We have installed already many APM systems. So how can we now achieve the zero trust system from F5 itself? And therefore, we are going to show you some use cases. A first use case is a typical login password system for application 1. And then suddenly, he wants to reach out to application 2. By default, MFA or APM system will tell us, okay, we already found a session for this specific user, so he can use that application. Within our APM policy, we tell the system, nope, that's not true. Why? Our user has to do some MFA extra checks before he can use application 2. Then, Bob is already granted for application 1 and application 2. And in application 1, we have some sensitive parts in this application. So therefore, before he is allowed to log in into the sensitive part, we are going to check a group. Maybe we can ask the Bob again to re-authenticate himself or to do a second time an MFA to prove that Bob is a user Bob again using the sensitive part of application 1. Another use case is step-up authentication. So therefore, we are going to tell the Bob, okay, before we do maybe the sensitive part of the application, we are going to start some certificates exchanging by doing some certificate authentication. And then the last thing is, till now, we only check the identity of the user, but we do not want you to check only the identity of the user. We only also want to check the security of the device itself, because we do not allow, zero trust tells us, we do not allow or we do not trust any device. So how can we do it? Is by doing a continuous check to the device itself if something will change on the device. For example, the firewall, is it still running? The antivirus system, has it still the latest database running? So therefore, when the firewall is not changed, when the firewall is on, he can allow. But when something changes on the system itself during the logon process, at that moment, my system will tell us, okay, you are not allowed to log on to the user's application and your authentication system will be closed. So that's the continuously device poster check, which tells us, okay, there is something changed on the device, and at that moment, the login will be disallowed. And then we can integrate also with third-party security checks, for example, with MDM systems, with typical risk engines, where we can say at a certain moment in time, that's what we can do in the future. So from version 15 onwards, and that's the one that we are focused on, is what is released in version 15 is that there is a new per request policy system integrated into RF5, where we are going to control the requests from the clients request per request. We have also a new mechanism on the F5 where we do a continuous device check. So when something changes on the device, which is not allowed anymore, we will tell the user, okay, you are not allowed to use this application again. What's also the advantage of the F5 system itself is that we are going to use also some templates. These templates, they will foresee us that we can have a control of the authentication mechanism, that we can have control of the device security posture checks, that we will control the access to our applications itself, and it doesn't bother us anymore if we are going to log in our network or outside our network. We have only one control point in our network where we say, okay, from that moment onwards, our user will be checked before he can use his application. In F5, as of version 15, we have now new templates where we have these guided configuration templates where we see, okay, the only thing that we have to do to fulfill these templates, and then we can start with the basic configuration of our system. When we start with this template, you see we have some questions that we have to fulfill. We have some answers that we can create. And at a certain moment in time, at the end, we are going to create an application and we can start to test this application. And that's what the demo will be. It's just when we have the application itself, we are going to show you how the application is created, and we are going to show you how it is working. Here, in this slide here, this part of the screen, you see also the different integrations that we have at the moment. If it's not an MFA provider, which is listed, it's also possible to create your own MFA provider or to integrate your own MFA provider. So Koen will now start to do some demos on the Zero Trust part. If there are any questions, please raise your hand or just send us a chat. And when that's done, then we can continue. Any questions from anyone? Not now. Okay, so I will ask Koen to do the demo, and then afterwards I will come back to you. Koen?
Okay, can you see my screen? And
yep, I can.
No, okay. So first of all, let's lay out the different players in the demo. I have a Windows machine that I will use to show the functionality. It will be connecting to two big IPs. Why two? You will see that later on in the demo. On those two machines, I have two virtual servers with a bunch of applications configured on them. Okay, all those applications are running on a web server in the backend and are front-ended by the big IPs with a zero trust configuration on them. What I also have in the backend is an Active Directory for authentication purposes. I have a certificate authority with an OCSP responder, so we can do on-demand certificate authentication. I have a radio server that I'll be using for step-up or multi-factor authentication. And I also have a typical EDA ID as a service provider, Okta, which some of you may use. Okay, so first of all, let's have a look at the configuration on the big IPs before diving into the demo or the test itself. So what Thierry was referring to is the guided configuration, which is a new addition in the latest firmwares of F5. And if you click here, you can, in an automated way, run through pretty complex configurations. For example, set up the F5 as an OAuth client and resource server. It's a guided configuration in this case. We have it also for as an exchange to configure Exchange proxy or ADFS proxy. We have it to secure your APIs. And we also have it for an identity-aware proxy. Okay, so that's what I'll be showing you. So this is Big IP1, one of the two machines. Let me show you through the configuration or what I did. So the first question is device. Do you want to use device posture checks? So that means, are you going to check the client to see if it fulfills certain features or settings. In this case, for example, it is imperative that the Windows firewall, and this account, this is for Windows machines, of course, if the Windows firewall is active. Here, select the browsers, check if antivirus, for example, is up to date or not, check if the firewall is active, hard disk encryption, etc. We also do this for macOS. So I'm going to be honest with you, it's not very extensive at this moment, but this is in continuous development. So if you, in the following iteration, we may, for example, be able to check which type of firewall or which type of antivirus is present, okay? So this is the first thing that we, the first thing that, or the first configuration part, and later we will bring all those parts together. Second thing is the virtual server. We have only one virtual server or only one IP address where we connect to, and depending on the host name used, we will send it to different endpoints. The third part of the configuration is establishing the authentication servers. So in this case, I have configured 4 of them, or 3 of them, let's say 3 different types. First one is an Active Directory, f5lab.local. The second one is a SAML IDP. In this case, it's Okta for 2 different applications, application 1 and application 4. And then I have a certificate, an OCSP, let's say a certificate authority that I configured, against which we can check if a certificate is present or not. What else can you use? We can use AAA servers like Active Directory, LDAP, Radius, or HTTP. We can use OAuth, we can use SAML, and we can use on-demand certificate authentication, all in the front end, okay? So next step is, will we need multi-factor authentication? Well, in the case of this, whoops, I changed something, well, never mind. In this case, for this big IP, I'm not using multi-factor authentication. I will be using on the second big IP. We can do single sign-on. So that means once a user is authenticated on the front end or on the F5, we can reuse these credentials to log him in to backend applications. In this case, it's Kerberos, but we also support HTTP Basic, where we will insert the credentials or the username, for example, in an HTTP header. Then it's time to configure the applications themselves. Okay, so these are web servers that I configured on the backend. Nothing special there. It's just a 443 or an HTTP server in the backend. It can be, in this case, it's one single server. It can be multiple, of course, and then we can load balance across them. You can also group different applications for single sign-on purposes or just management purposes, for example. In this case, I have an application group, app 2 and app 3. And you will see that once I authenticate to application 2, I will have single sign-on for application 3 as well. These are all the elements up till now. And in this screen, contextual access, you bring everything together. For example, for application 1, if you want to access that one, you will be redirected to Okta for SAML authentication. And at the same time, I will check if the Windows firewall is active or not. For application 2 and 3, I will do on-demand certificate. For application 4, I will do, again, SAML, but no posture checks there, okay? Then the latest part is some customization. You can, as you all well know, customize the landing page of the big IP the way you want it. In this case, it's pretty straightforward, but of course you can respond to all to checks, for example, with custom messages, etc. Okay. Now, if I were to deploy this, what would come out of here is a really complex configuration, okay? If you would have to make this manually, it would take you hours and hours. In this case, if you have all the elements available, it's work of a couple of minutes, okay? So you can see here, for example, in this case, if the first step we do is check the URL, and then based on the URL, we go through the configuration just like we created it in the wizard, okay? So that's it for the setup for Big IP1. Let's now do some tests. So I'm on the Windows 10 machine again. With these types of tests, you also always need an incognito window, or you may have problems. So what can I also show you? Oh, wait, let me show it right here. Yep. Okay. At this moment, nobody has connected to the Big IP. That's another thing that I can show you. So no active sessions. The moment I click on, all right. Maybe, wait, let me do something else. Let me start this one first. Application 2. So in this case, what we'll do is on-demand certificates check. So the moment I click here, the browser asks me which certificates do you want to use. If it's not present, I will not be authenticated. I will not have access to the backend. In this case, it works. I come on it's just a sample application, nothing special here. Okay. Now, in the workflow, we defined that if you authenticate to application 2, you will be also authenticated to application 3. So let me check that. Yes, in this case, I am also single sign-on, in a way of speaking, to this application. Everything seems to work fine. Okay, then for the latest one, application 4. This is SAML with no endpoint checks. So I am being redirected, force of habit, Okta users, to Okta, to the ID as a service in the cloud. I need to specify a username and a password. And once I type that in, and hopefully it's correct, I got a cookie and I am now connected to application 4. Okay, let me quickly revert back to, oh no, let me do something else first. This may be a demo problem. The demo gods are not happy with me. Let's see. Okay, the firewall is active. So if everything goes well, I should be able to connect to this guy. But yeah, I know what the problem is. It's a certificate problem. Maybe I can fix it by the end during the Q&A. So let me skip that. No worries. I have some other stuff here. So I'm now going to the Big IP 2. And the nice thing here is I'm not going to run over all the details. Just going to the contextual access. So I have application 5 with Okta SAML. Now, the thing is, I've been connected to Okta with Big IP 1, so I should have single sign-on for this application. Application 6 is multi-factor. You will see that I will have to authenticate with Active Directory first. And once that's done, I have a certificate or an on-demand certificate. And application 7 is an example of multi-factor authentication, or rather step-up authentication. In application 7, I have a directory where I will have to do radius authentication before I can access it. Okay, so back to my demo machine app. Let me start up a new incognito window. Click application 5, and what happens? You briefly saw in the menu bar that I was redirected to Okta, but Okta saw that I was already authenticated on the first big IP, so it lets me access this new application as well. So that's a single sign-on in action. What else is there? Big IP 2, application 6. If I try to access this one, I will have to perform Active Directory authentication. So my domain is F5 lab. Oops. Backslash. Where is the backslash? Wait, I will try without users. Okay, and what you see here is I'm doing Active Directory authentication. And then as a second factor authentication, it's looking for certificates. So this was multi-factor authentication in action. And then as the latest one, I have application 7, where I can demonstrate step-up authentication. So if I click here, I'm automatically authenticated. And what happened here is Active Directory authentication. But since I am already authenticated through application 6, I did not have to do anything anymore. Now, the thing is, if I click on the examples window, I will be stopped. This might be, for example, a critical application or a critical directory on the web server where only certain people have access to. So in this case, I need to provide radius authentication. And if that is correct, I get an access here. Okay. So that's in a nutshell what we can do here. So what you will see here is an active session, and I have different subsessions. Now, what is important here is that this is per request authentication. So every time I click, I will get checked if, for example, the Windows firewall is still active, if I'm still authenticated, if my user is still active, etc. So every minute, the status of the user is also refreshed to check if I still have the rights, the necessary rights to access what I am accessing. And the moment something changes, I might get kicked out. Okay, so that's it for the demo for me. Back to you, Thierry. Any questions?
Okay, thank you, Koen. But before we continue with the Q&A, let me take over the screen again and to do a small, where is my presentation here? I'm looking for my presentation. Here it is. So in my presentation itself, and maybe you've seen it while Koen was explaining, there are some new items added. So in the past, we only worked with a session policy. Now, as Koen already mentioned, we added a new functionality per request policy. And the only thing that the per request policy is doing, it's re-evaluating every HTTP or HTTPS request policy. So in that policy itself, what we can add, we can only add extra authentication rules, some extra endpoint checks. So at that moment, we have our end poster check also configured. Inside that request policy, like Koen already stated, we can configure many different things regarding authentication if you want to add multi-factor authentication in itself. Within that request policy, network request policy, we can also configure subroutines. In a subroutine, we can at that moment add another subroutines. And that's also something new within our per request policy. Instead of macros, we are going to use subroutines to define some specific parts in our policy itself. And this subroutine at that moment is going to create you a new subsession. So Kunst showed us a session table where we've seen our authenticated session within our session policy. And then, sorry, we will see new sessions evaluated based on the per request policy. So that moment, we will create also a new device posture check, and this device posture check is where zero trust has been, the zero trust model has been enabled, is now depending on a new client, new agent called the F5 access guard. And that F5 access guard, which is available on macOS and Windows, sorry guys, will insert a header, will insert an HTTP header, which is then be used to control the device itself at always, to have always a control to have these type of checks on your device itself, on your end device itself. That's it from my part. So at the end, that's our goal, is to create some extra visibilities on our backups, on our clients itself, on our applications, to do some security views and so on. I'm going to unmute you. I'm going to able to allow you to speak, so that everyone can speak. If there are any questions, just let us know.
Any questions about the demo?
Maybe one question. How do you think to handle the proliferation you have in OSs, antiviruses, device types, and so on in this device checking? If an application is open for whole world, then experience learns that it is not really manageable.
Yeah, it's I agree. It's a hard thing to do, of course. It's like I say, we are going to extend it. If you look at the big IP edge client right now, we can do a whole lot more than we can do right now with the what we do here. So I believe it will be extended, but we will focus on Windows, macOS, and Linux for endpoint checks. We can do high-level checks for others. We can do OS detection, for example, for other stuff. What else could we do? Possibly, I'm not saying it will be like that, but another possibility would be, for example, we have the mobile SDK that would allow us to check if, for example, an Android or an iOS has been rooted or jailbroken. Yeah. But it's a work in development. I agree with you. It's hard doing that. Yeah.
Any other questions? Okay. So before we are ending the session, everyone is probably also aware that the Exclusive Networks is a training center. On our website, it is shown that we are hosting different trainings in the future. So there is the LTM bootcamp, the APN configuration session, and the advanced WAF configuration session, which we hold during the months of May and June. So if you're interested, if you know someone that's interested, please notify us, and then we will start with the subscriptions, and we will start with these trainings also. So that's it from my part. So now it's for Stefan if he wants to show, to do some review sessions. Stefan?
Yes, hey, if there are no longer any questions, we would like to do very fast a small Kahoot just to get